All right, 6.6, use proportionality theorems. So this section is going to be a lot more math and less of our proofs, but we're going to still use that idea of our similar figures. So we start out right away with two theorems. If a line parallel to one side of a triangle intersects the other two sides, it will divide the two sides proportionally. So I see my parallel sides, and that means that like this side here, QT, is going to be in proportion with the one below it, so SU, and then this side over here, TR, is proportional to this one down here, which is UR, okay? So we're going to get these proportional things. And one thing I'm going to tell you as we set it up, so I just did top to bottom, top to bottom. You could also do left to right, left to right. It depends what you want to do. So there's more than one way to set up the proportion, which we already know from earlier in the chapter. But you need to just make sure you set up an equal proportion and keep your side segments where they need to be. Okay, one thing and I need to think about if this goes into, I guess we'll catch this later, so I won't go into that right now. For 6.5 then, it's the converse, and we know from chapter 2 that the converse just flips the order of the information given. And this one says if your sides are already proportional, then your two sides that split those must be parallel as well, okay? So it'll be parallel to the third side. So it's just the flip, saying if they're already proportional, so they give us the proportional, then the sides are going to be parallel, okay? To be honest, the math we do will look the same. It's just how we present the information. Okay, so on our first example here, we know that QS and UT are parallel. They tell us up here and they show us with the arrows that those are parallel. And I didn't do a good job of copying those arrows. They tell us RQ is 10, RS is 12, ST is 6, and we are looking for QU, so I'm going to throw an X right there, okay? So we have this option of setting these up, and I'll tell you right now, they did them top to bottom. So on the left side, they did RQ on top and QU on the bottom. On the right side, we have RS on the top and ST on the bottom. So let's fill in our values. RQ is 10 over, they have QU, I'm going to just put an X there because it's easier for us mathematically to see that. RS is 12, ST is 6. It's equal. We have a proportion, we can multiply the extremes. 10 times 6 is 60. 12 times x is 12x. Again, I'm going to make that QU my x. And to solve, I divide by 12, and I'm going to get QU is 5, or my x is 5. Okay, so we did top to bottom, and we're able to solve that. Those parallel lines divide it proportionally, so it allows us to set up that proportion. So let's look at page 2 at the top. Okay. And we see this picture here of a spoiler for a remote control car, okay? And we're looking just at the end of it here. It's hard to see that, so I'm actually going to come draw it a little bigger over here so I can see what I'm looking at. I have I have a dashed line here, right? There's my B, C, D, and E. Okay, so I want to see it a little bit bigger because they gave me these dimensions. AB is 31 millimeters. BC is 19 millimeters. CD is 27 millimeters, and DE is 23 millimeters. And I want to know, is BD parallel to AE? Actually, they already told me it's not parallel. They want me to say why I know that. Okay, so we want to set up a proportion, okay? They, once again, have set it up kind of top to bottom. So on the left side, CD is 27, and DE is 23. Can we reduce those? No, 23 has nothing we can reduce by, so we can't do anything. On the right side, top to bottom, CB there is 19, and BA there is 31. Can I reduce those? No, 19 and 31 are both prime numbers, neither one reduced. So because I can't reduce them, I cannot make those fractions look the same or those ratios look identical. The other thing you can always do too if you're not sure, like, oh, did I miss a number? Cross multiply them, right? If I cross multiplied them, where did I set my calculator? 27 times 31, that's 837 on my extremes. 19 times 23 is 437 on my means. So obviously not even close to being the same number, right? So because these are not equal, we know that these are not equal either, and Because they're not proportional, they cannot be parallel, okay? All right, finding the length of KL here, okay? I'm going to put an X right there. Your choice. I see these parallel lines, so I know my sides are proportional. I can either do top to bottom or left to right. I'm going to show you a left to right, just so you know what I'm looking at. Left to right, on the top up there, I'm going to go 18 over X. And on the bottom, from left to right, I'm going to do 24 over 44, okay? Just a quick note, notice these 18 and 24s. I didn't put them in the same fraction, but they're across from each other, okay? They're both on top. So they either need to be 18 over 24, or like this, 18 on the top on the one and 24 on the top on the other. So we still kind of put them together, but sometimes they're up and down from each other, and sometimes they're across from each other. My proportion's set up, I'm ready to go. When I multiply 18 times 44 for my extremes, I get 792. And 24 times x for my means gives me 24x. Divide both sides by 24, and I find x is 33. And we know that x I put up there for KL. So that's what I was looking for, was that KL. All right, number 2 is similar to the top up there. It says, are these parallel? So we know we want to have proportional sides, okay? And again, your choice, top to bottom, left to right, doesn't matter. Just so we have another example, I'm going to do top to bottom, so it's a little different from the one above. So on the top, I see 18, and it should go with the 36 on the bottom. I like that, easy to reduce. Oops, I don't want to divide by 2. I want to divide by 18, because then I get 1 over 2. Okay, my brain was telling me 2, but not in the right spot. Okay, another top to bottom, 38 on top, and that is an 80 on the bottom. Ooh, divide by 2 maybe, and I get 19 over 20. It's super close. Oh my goodness. I really need you to be here to correct these for me. 19 over 40. Super close to being 1/2, but I would need to be 20 over 40, and I can't make 38 go to 20. So these are not the same ratios. So these are not similar. So what am I trying to say here? Not similar. Of course they're not similar. But what I really want to write is that my sides, QT and RS, notice I put the parallel sign and I'm going to cross it off. They're not parallel because my ratios are not the same. All right, moving on to page 3. 2 more theorems here, and this is what I was kind of checking on earlier. I couldn't remember if I had them here in my notes or not, but they are. We said earlier if I had a triangle and I made the third side, took the third side and made a parallel side, I'm proportional. This is just saying it doesn't even matter how many lines you have. So every time you have some lines and you have parallel transversals coming through them, they will always break those segments into proportional segments, okay? Okay, so even up here at top, it's not a full shape, but this UW here is with the YW, and then the UW is going to be the same as the VX with the XZ, okay? So proportional. So again, it's not triangles, but it's still proportional. Okay, for the next theorem, if a ray bisects an angle of a triangle, and this is super important to know. We talked about these back in chapter 5, angle bisectors. So my angle is split equally. That does not mean that these portions down here are split equally, because the angle bisector is different than the median. So don't think just because the angle's cut in half that the sides are cut in half, that it cuts over too. So they are not, but what they are is proportional. So if a ray bisects an angle of a triangle, it divides the opposite side into a segment whose lengths are proportional. Wow, my writing's not great there. To the lengths of the other two sides. Okay, this AD is going to be proportional to the side it's closest to, AC. And this DB is proportional to its closest side, which is, I guess I'll call it B8 to kind of keep my pattern the same. Okay, so one way I sometimes do that, and it will set it up slightly different than what you see right here, is I might say split side with its adjacent side. Okay, so this split here with its adjacent over here is going to equal the split side with its adjacent side. And remember from earlier, adjacent side means the side that it's touching, okay? All right, so lots of notes there. And now I'm going to go straight into the margin and give us some more notes. And we might get slightly confused, but I'm hoping by the time I'm done doing some examples, you feel a little bit better. Okay, so that Theorem 6.6, which says I can keep throwing more parallel lines in there and keep dividing things proportionally. So what I have over here in the margin is this side segments are proportional to side segments, okay? So it really doesn't matter where you're at on this, but as long as you're like left to right, you can do all kinds. So I could have segment AD on the left, and it's proportional to AE on the right, okay? I could have DF on the left, proportional to EG on the right. I can have FB on the left, proportional to GC on the right, okay? But I want to state this one too. I don't have to go little segments. I could go from like here. I could go like B to D all the way to C to E, okay? I could like add two of them together if I wanted. And I can really, it doesn't really matter what, I can just use any of those two, okay? So that's what you want to know here and what you want to see, okay? All right, now the second rule though, this is the one that you really need to pay a lot more attention to, okay? And this is the one that if you don't pay attention to it, sorry, I thought that was the eraser, you're going to be very confused later and not get correct answers. So this second one, parallel sides are proportional to complete sides, okay? So my parallel sides are these that are here, that are parallel, okay? So when I compare those, I don't have other parallel sides. I have to choose something on the side. What's really important is you need to choose right or left. Okay, you can't just say, well, I'll do the left on this side and the right on this side or whatever. No, you've got to choose one of them and stick with it. Okay, so let me kind of give you some ideas what's going on here, and you really need to pay attention to where I'm coming from the picture. Okay, DE here, and by the way, I'm going to start on the right, okay, just so you see this. DE is going to go to its side back to the top, which is EA. That's its complete side, okay? Now, the next one will hopefully make this make a little more sense. FG here needs to go to its complete side, which starts at G and goes all the way to the top, which is GA. Oops. Okay, so notice it started at G and went all the way to the top. And then this side, BC, when it's parallel, it needs to go to its complete side, which starts down here at C and goes all the way to the top, CA, okay? And the same thing would happen if we went on the left side. So these are all the ones from the right. So if I went to the left side, I might say DE, and it to go to the top, it would be DA, okay? And then FG, now if I go to the left side here, it's going to go all the way to the top, so it would be FA, okay? And the final one there, if I did BC on the bottom, it would have to go all the way to the top here with BA, okay? So this would be if I worked with the left side, okay? So you kind of have to choose a side and then stick to that side for all those problems. Now, you'll notice I have lots of things in my proportion. I need to choose two of those to be able to set up something to solve, okay? Now, I gave you all that right now. We're not going to do an example of it till the other side, to the next page, okay? So let me do example 3, then we'll turn the page, and we might need to just flip right back to this and look at these notes again, okay? So let's do example 3. A farmer's land is divided by a newly constructed interstate. The distances shown are in meters. Find the distance CA between the north and the south border. Okay, so one thing I want you to note right here from C to A, okay, that's this whole thing. I'm going to be honest, I would rather put an X just on BC and find a small portion and then add it back on and find CA. It's just easier to set up, okay? Because I'm going to do that, what I'm going to do too is I'm going to just kind of get rid of what they're doing and we'll do it our way, okay? So I see my parallel lines, right? So everything's in proportion. I'm going to go top to bottom because it's easy right now. On the left side, I see 2,000, and I put my X on the bottom. And then on the right side, I see 2,500 and 3,000, okay? Top to bottom, it's proportional because of the parallel lines. Multiply your extremes. 2,000 times 3,000, that's a 6 with 6 zeros. about 6 million there. And then on the right, when I do the extremes, I get 2,500x. Divide 6 million by 2,500. Hopefully you have a calculator for that. And I get 2,400. Okay, now remember, that's from B to C is 2,400. So when they ask me from A to C, what's the distance from the north border to the south border, I'm just going to add those 2,000 plus that 2,400 I just got, and I get 4,400. And it looks like we're in meters, right? Okay. So top to bottom, left to right, that's kind of the easier setup. All right, last page of notes. Okay. Where do I want to start? I want to start in the margin, and then we'll come back over and do the ones over here. So in the margin, this picture looks similar to that margin note I just got through explaining about side segments, proportional side segments, complete sides with the parallel sides, okay? I have 4 variables here. I'm looking for an x, a y, an a, and a b, okay? I'm going to start with the x and the y because they're on the sides, and these are straightforward. When you're on the side segments, they're proportional to another side segment. So I'm looking at x and thinking, you know what, it should go to 4. I need another side segments that both have numbers. How about going with 6 and 3, okay? So if I want to go top to bottom here, I have 3 over 4 on the left. I have 6 over x on the right. I'm set up. I get 3x equals 24 when I cross multiply, and x equals 8. Nice and easy, okay? When I go to do the y, let me change colors so I don't get confused here. When I go to do the y, I know that this y right here probably goes with this 5 right here because it's across from it, okay? Now, I can use anything from above to do that. I'm actually going to do a jump, and I'm going to go back up to the 3 and the 6, okay? So if I start top to bottom again, my top number is 3, my bottom this time is 5. On the right side, my top number is 6, and my bottom is y. And you're allowed to skip that middle segments. You don't have to worry about them. Even though we know now that it's 8, I don't care. You need one set of segments with one set of segments. I cross multiply, I get 3y equals 30, and y equals 10. Okay? So far, so good? That makes sense, right? Side segments with side segments. It's a pretty straightforward one. Now, the tricky ones come when we go for these parallel lines, okay? So one thing we need to do, and I told you this earlier, is you need to decide to work either left side or right side. Because we solved for the right side, and there's a chance we made a mistake, I don't like to use numbers I've solved for. I like to use numbers they gave me. So I'm going to choose to work the right side, okay? So I'm just kind of giving you that heads up that my choice is the right side, or, oh my goodness, that's the left side. My side is the left side because those numbers were all given to me to start with. Okay, so if I'm going for A, now this time I'm going to tell you, I'm going to do the parallel side on top with its complete side. And that's my reminder to you that I need that. Okay, so my parallel side here is A. Its complete side needs to start here all the way to the top. So it's 4 plus 3, which is 7. Okay, I need another parallel side that I know the number of. So it looks like I'm going to do this 4. And its top, complete side to the top, is 3. Okay, so there's my setup. I'm going to get a decimal, I can already tell. 3a equals 28. So it looks like a is going to be about 9.3. I rounded there, okay? So a is about 9.3. Okay, one more to go. Trying to make sure I can fit it in without losing my picture. This time I'm looking for B. Once again, I'm using this setup of parallel side to complete side. So if I'm looking for B, its complete side, again, I'm going to start up this left, goes all the way to the top, 5 plus 4 plus 3, so it's 12, okay? What do I want to use? I could go back to the A, but I know I rounded that. I'd rather not. So I'm going to go right back to the top one again and go 4 and go complete side, which is 3. So don't want to be erasing things. Come on. 4 was the parallel side, and its complete side is 3. So I'm looking at this right here. There's my setup. Cross multiply. I get 3b equals 48, and I find that b equals 16. Okay? So important when you work with the parallel side to work with a complete side. And you choose like all on the left or all on the right. Just make sure you stay on the same side and you're consistent, okay? I definitely have some of those on the homework worksheet, so I definitely want you to practice them. And remember, homework is practice. If you make a mistake, that's what we're going to learn from. It's okay to make the mistake, but practice and try to remember these notes I've given you. All right, now we're over here to this one, and we're talking about those angle bisector problems, okay? So it tells us my two angles are equal, which makes EG my angle bisector. So as soon as I know I have my angle bisector, I'm thinking of this setup of split side over adjacent side equals my split side over my adjacent side, okay? And I don't think that's how the book put it at all. So I'm going to start with my split side and adjacent side. Okay, I do have a problem that they gave me sides of 8 and 12, and the whole side down here is 14, and they called this side x. What can I call the other side of the split? Okay, so I'll throw out you a scenario. What if I found that x was 4? What would the other side of the split be? 10. How do we get that? We took 14 minus 4. What if I said the left side was 7? Well, then the right side would be 7 because we do 14 minus 7. Every time we do 14 minus whatever number it is. So because of that, I can call this side 14 minus x because whatever I get, I'm going to subtract from 14. Okay, so I'm thinking split side over adjacent, okay? And by the way, I don't even like where the x is. So this x is one of my split sides, okay? And its adjacent side is 8. This split side is 14 minus x, and its adjacent side is 12. There's my setup. I'm ready to go. So extremes, 12 times x, means 8 times 14 minus x, okay? I need to distribute. I'm going to get 12x. 8 times 14 is 112. 8 times x is negative 8x. I'm going to add 8x to the other side. Divide by 20, I don't get a whole number, I get 5.6, okay? Which means one side is 5.6, I subtract that from 14, and my other side is 8.4. And if we check, and we go 5.6 over 8, and 8.4 over 12, again, the easy way to check these is to cross multiply. 5.6 times 12 is 67.2. 8.4 times 8 is 67.2. They are equal, so these are a good ratio. Okay? Split over adjacent equals split over adjacent. A couple more examples to do, and we'll finish out these notes. We're looking for the length from A to B right there. Okay? I see that I'm split proportionally, I'm split with parallel lines, which means the sides are proportional. I just need to choose top to bottom, left to right. Doesn't matter. Let's try a left to right this time. Okay, across the top, left to right. 24 on left, 32 on right. Across the bottom, 27 on the left, x on the right. You need to just stay organized. That's the key. Cross multiply, 24 times x for my extremes, 32 times 27 for my means, and I get 864. Divide that by my 24. And I get 36, and that will be for my AB. I always double check, is that all I needed to do? It is right there. I don't need to add it to anything, because sometimes I find the smaller part, right? And then I would have to add it to the 27 or something, but I don't need to this time. All right, last problem here. And I'm looking for some hints on what I can do, and I see that my angles down here are equal, which means I have an angle bisect, which means I have this setup that the split over the adjacent equals the split over the adjacent, okay? So here's my split on the top, and OAB is what I'm looking for. So my 2 is the split, it's adjacent to x. My split here is the 1, and it's adjacent to square root of 2. I cross multiply my extremes, 2 times square root of 2, because they are not both the same, I just hook them together. Excuse me. And 1 times x is x. I'm done. Excuse me. All right, your homework is going to be a worksheet. You need to keep these notes handy to make sure you're setting them up correctly, and please show the setups. Do not just write down x equals 36 or whatever you get. Show the setup so if we have trouble later, we can look back and say, wait, did you put left over right or top over bottom, or did we get confused and mix them up, and that's why we're getting the wrong answer. Please show the setup, and then you can use your calculator to find the answers. Please let me know if you have any questions.